to construct a circuit that can force the direction of the current to change, we use transistors, and that's what we're going to talk about in this part. If you remember, when we talked about diodes, we talked about the analogy with a flapper valve. And here we show it closed, but if the valve is under enough pressure differential from the top to the bottom, the flaps will open up and allow fluid to flow through. So this is analogous to our diode, which has this symbol. But what we would like to do is have the ability to control that flow from an external device or an external control. And so the analogy for that, which is a transistor, is more like a valve for a water faucet or your kitchen sink. So you again have a valve in the middle of a pipe, but we have a handle attached to it that we can control the flow and turn it off. So if we go to our transistor, a very simple picture looks like this. We have a source signified by S, a drain signified by D, and the analogy to the kitchen faucet valve is we have a gate. So this is analogous to the handle on the kitchen valve. Our diode was a two-terminal device. So we basically had a way to get current in and a way to get current out. Now, in the case of transistor, again, we're going to use a special transistor called a MOSFET, or FET. And FET stands for Field Effect Transistor. The key point is that the FET has 3 terminals, not 2. And that third terminal, the gate, is what allows us to control the flow through the transistor. So I'm going to draw a simple diagram of a FET here. And it's oriented like our diode in this case. So we have a source here, a drain here, and the current is going to flow this way through the device from top to bottom, just like in the diode. But instead of turning on automatically like the diode due to voltage between these 2 points, in the transistor we also have the gate, or G, and a voltage applied here at the gate allows current to flow between the source and the drain. So we've now moved from a 2-terminal device that is controlled by the voltage across it to a 3-terminal device that can be controlled by this third input called the gate. And now we are ready for part 7 of our videos for this module, and it is called Designing the DC to AC Inverter, a Systems Perspective.